we're asked to find the general solution of this differential equation. And so in order to do that, the main thing we need to remember is that we need to use separation of variables. So reminder, separation, I'm going to write that, separation of variables. It's exactly what it sounds like. We want to get all of the variables of one type on one side and the others on the other side. And so in this case, I see that we have dy over dx equals y cosine x. So let's get all the y's on the left and the x's on the right. In order to do that, I'm going to have to divide by y on both sides. So I'm going to get dy over dx times 1 over y equals cosine x. And then I'm going to multiply dx on both sides. So I get 1 over y dy equals cosine x dx. And remember, this dy dx is not actually a fraction. Dy over dx is Leibniz notation to represent the derivative. However, we can use it like a fraction in this case, which is why it's really convenient. Now what do? Well, we have to find our antiderivative, the integral. So we're going to integrate on both sides. We're going to find the antiderivative. What's the antiderivative of 1 over y? We'll remember that is ln, the natural log of y, equals, and the antiderivative of cosine of x, antiderivative of cosine of x will be sine of x. And then plus c, because we need to add that constant term because it's a general indefinite integral. All right, now what's next? We want to get y by itself, and the way we do that is we exponentiate. I'm going to write that here again. We are going to exponentiate, which means to raise everything to an exponent. So we're putting it all in the exponent. So in this case, our base is going to be e, so we can get rid of that natural log. So e to the power of ln of y equals e to the power of, and we take everything and we put it into the exponent, sine x plus c. On the left, we know that the y's, or that e and the ln will cancel, so we're going to just be left with y. So we get y equals e to the sine x plus c. And then we have to remember, or we want to remember that rule that tells us that if we're adding that c in the exponent, that's the same as multiplying by e to the c. So I can rewrite it, e to the sine x times e to the power of c. And e is a constant, so it just being raised to another constant will give us a constant. So I can rewrite that e to the c as just a big capital C. And so we'll find that our final answer, I'll write it up here, maybe in green so we can see it separately, is going to be y equals c e to the power of sine x. We found this general solution by using separation of variables.